testing live HLS. It's can be a pain. It can be a pain to get the data you need. You know, sometimes you'll end up with a webcam and you're staring yourself while you're debugging a stream. I mean, I know I don't want to stare at myself for 2 hours. You know, so you could set up a live stream server, but what if you need to inject 608 captions, or you want to test 608 in live or any other type of data? How do you do that? I'm Michael Roca. I'm the Senior Software Engineer and Test at Brightcove. It's my job to ensure that we have the tools we need to thoroughly test our product. This is why I created a tool called Murphy. Essentially, Murphy simulates live streams on the fly. It converts HLS VOD manifests into a live stream. So the benefits of this is, like I mentioned before, we get a variety of content. So if we have a portfolio of test data, you know, say you want to test alternate audio tracks or misaligned renditions, 608 captions, you have a much greater portfolio of test data. It's much easier to set up than a live stream. And it also makes it easier to set up automation. If you're simulating live data, you can expand your automation tests significantly. So how does it work? What it does is it parses you feed it in a master manifest. It parses the data. It identifies all the renditions. It'll also identify any VTT caption manifests and alternate audio tracks. And it will start a stream for each rendition at the same time. So each rendition will be parsed and loaded into memory. You can see this here, how it's parsing the header, getting all the data. It identifies each segment and saves all the data from that, the file, the header. It also gets the start time of each, it memorizes the start time of each stream, so it knows how to serve it up later. And as you can see right here, it's a sliding window. So you'll see on the left there is a sliding window happening. Every time a segment drops off the manifest, you see on the right there is you'll see the segments being hosted at this time. You'll see the media sequence increases every time a segment drops off the manifest. And as time goes by, you'll see that it continue to decrease. But what happens when it gets to the end of the manifest? It throws a discontinuity and starts the stream over again. So as you'll see here, the first segment is the last one on the simulated stream. And it'll continue to loop this over and over again indefinitely until you shut off the server. And as the discontinuity drops off the manifest, the discontinuity sequence is increased by 1, and the process is continued. You'll also notice here that the segments in the original manifest and the segments in the simulated stream, they don't look the same. It's simply because Murphy is hosting out each segment and pulling it from the original source, but serving it up on the fly as they're requested. This essentially allows Murphy to run without CORS errors. So a lot of browsers will throw a CORS error if the segment domain is different from the manifest domain. So this eliminates that problem. And Murphy also supports event mode. So instead of a sliding window, we have an expanding window. So as time goes by, you'll notice that it continues down, and as soon as it gets to the end, instead of starting this one over, like a normal event, the most common use case is once the event is over, it's just a simple VOD file. So Murphy will throw the end list, add the end list to the end, and Murphy will host it as a VOD file from then on. Here's a little demo of how Murphy works. So as you can see here, Murphy is, this is just a normal manifest. There's nothing special about this. We're just, and you'll notice I just started Murphy here in the demo, and now I'm giving the master manifest, the original manifest, filtering that into Murphy, and now it is, this is a normal live stream. It's acting just like it's a normal live stream, except it's taking it all from the original content. And you'll see once it gets to the end, it goes back to the beginning and continues, and it'll continue indefinitely until the server's done. So Murphy also, it supports error injection. So this comes in handy when you want to throw, when you want to test in situations that aren't ideal. You can, for instance, we were doing rendition failover testing, meaning if we sensed an error, or if there's an error detected in one of the streams, there's corrupted data, or it just couldn't pull a TS file, instead of the player failing, the rendition would get blacklisted temporarily and switch to a different rendition. So this was very helpful in testing that sort of scenario. There are other ways of doing it, but this just made it simpler. And that's just a few of the scenarios. That's just one of the scenarios that we use to test Murphy. Now, Murphy is completely open source. Here's the link right here. Contributors are welcome because there is a lot more that can be added to this. Coming soon, we plan to add FMP4 support, as well as simulating errors in VOD. Now, we've only scratched the surface of the type of errors that we can add to Murphy. So we depend on the community to help us out and just add more scenarios, because there is a lot more that can go wrong in a stream than Murphy supports, and we would like to simulate that. Is there any questions?